compound inequalities. This is when we put two inequalities together. And if you master inequalities, this will make perfect sense. Sometimes a little bit confusing, but I'm going to try to make the most sense out of it as I can for you. So this graph really kind of puts all the situations. You can have both equations pointing the same way. You can have them pointing opposite ways, and then you have them pointing towards each other. And it depends upon if we have the word and or the word or, in which case what we're supposed to do here. So let's take a look. What's the difference between and or in math? So if you see the word and, that means it needs to satisfy both. If you see the word or, needs to just satisfy one of them. So let's take a look at this first example. We're going to solve each one individually. So we have 11x plus 4 is less than 15. Or 12x minus 7 is greater than negative 25. So we're using the word or this time. Solve for x. X is less than 1. Or and if I simplify that, 18 over 12, it's going to be negative. Divide each one by 2 is 9 over 6. Divide each of those by 3 is 3 over 2. So if we think about this on a number line, it's got to satisfy just one of them because the main word here is or. So x is less than 1. It's open and it's pointing to the left because it's less than. And x is greater than negative 3 over 2. That would be to the left of this. And it's open there as well and pointing to the right. So since it only has to satisfy one, this is actually going to be all values of x. And let me explain why. Because all numbers to the right of negative 3 over 2 will satisfy this one here on the right. The x is greater than negative 3 over 2. Or all numbers less than 1. That includes every single number on the number line. It can be any number over here because that'll be under the purple shading there. Or it could be any number under the green shading, which would be to the right of this spot, which would be every single spot on the number line. So that's all solutions will work. Let's take a look at this one. It's another or. Let's go ahead and solve it. Then for the other one, so let me do the number line. X is greater than 1. So let's start with this one. I'll do that in purple. And so x is greater than 1, or x is greater than or equal to 2. So we just have to satisfy one of these. So the green is already actually taken up with all the purple. So we really just have to answer with this. X is greater than 1 because that includes the x is greater than or equal to 2 as well. And it just has to satisfy one or the other. So we'll just go with the purple on that one, which is the x greater than 1. Let's look at and. So remember with this one, maybe it'll make a little bit more sense because it has to satisfy both. So subtract 14. Divide the negative 6. So that flips the inequality sign. Subtract 28. 3x is less than or equal to negative 3. Let's graph both of these. So we want negative 1, we want closed and to the left because it's less than negative 1. And then 7 is going to be open and to the right. Now it has to be a number that satisfies both of these. That would be our solution. But is that even possible? So if you think about that, negative 2. Is negative 2 less than negative 1? Yes. But is it also greater than 7? No. So it can't satisfy both of these. If you think of the number 0 between these two, is 0 greater than 7? No. Is it less than negative 1? No. So it does not pass for those as well. If you think of the number 8, 8 is greater than 7, but it's not also less than negative 1, so that one fails as well. So this would actually be that there are no solutions. All right, let's solve this one. Oops. So x is greater than negative 1. I'm not going through the solutions of these. You'd probably have to look at previous lessons. It's pretty simple to solve these. All right, so x is greater than negative 1. That's going to be an open point there, and everything to the right. And x is less than negative 1 is also an open point there, and everything to the left. So I think we're going to run into the same situation again, because it needs to satisfy both of these things here. So what's a number that's greater than negative 1? Well, negative 2. Let's go with positive 1. Positive 1 would be over here, but it's not less than negative 1, so it can't satisfy both of those. There's not a number that can satisfy both of these. If it included negative 1, maybe, but in this case, it would need them both to include it, so it doesn't do that. If you think of a number like less than negative 1, like negative 2 over here, yeah, negative 2 is less than negative 1, but it's not greater than negative 1, so there's no way to find any number that satisfies both of those. So there are no solutions. By the way, if you graph it and it's and, let's just say you end up in this situation with and, then the numbers in between would be your answer. So like 1 would be in this region and it would be in the green region. So it would satisfy both the purple and the green in this case. And your answer would look like this if you run into it. And you just gotta be careful if it's open or closed at 0, open or closed at 2. But that's what, if you do run into that, that's what that would look like. Anyways, I hope this helps. I know this can be a little bit confusing, but you just gotta kind of graph it and think about it. Remember, the main thing is for and, it needs to satisfy both. And for or, it just needs to satisfy one.